Today we will learn about linear differential equations and how to solve the linear differential equations. So here a differential equation in the form of dy by dx plus py equals to q is known as linear equation, where you can see this p and the q both either will be constant or in terms of x. So here to identify p and q is very important to solve the questions. So let's see some examples. So like this, the first one you can see it is dy by dx plus y equals to sine x. So here you can see I'll just show you what will be p and q also in the equation. So here you can see here you have dy, so y. Okay, so we don't have to take this. So you can see here the p will be 1, the coefficient of y is 1 here, and the q will be sine x, because in solving these questions this finding these p q is very important. Now let's see the second one. So here you can see here you have y, here also y, so your p will be 1 by x and your q will be e to the power x. And in questions it's not necessary that you will get this form only, so you just have to get this form also. So here dy y, now p will be 1 by x log x and q will be 1 by x. So basically in NCERT there were like two forms like this. One is dy by dx plus py equals to q, and for this linear also you have one more form, that is dx by dy plus px equals to q. But this form this year this form is not coming. You don't have to prepare this one, so only you have to prepare this thing for this year. Now let's see the rules of like how to solve the linear differential equation. So first thing, you have to obtain this thing dy by dx plus py equals to q. This form you have to obtain from the equations. And how you can do that, like first you will check, if you see a differential equation, first you can see if the variables are separable or not. Like the first method, like first you will separate the x and y, all the x together, y together. If it is okay, then go for the variable separation method, and if it's not okay, then you can check it for homogeneous equation, and if it is not homogeneous equation, then you can check if it is linear or not. So first you have to get this form, and then you have to find out the values of p and q. After getting the value of p and q, you have to find out the integrating factor. So you will find the integrating factor. So simply you can see integrating factor is equals to e raised to the power integration of p dx. So this you have to find here. And after getting the integrating factor, it's very easy to solve. So you just have to use this formula that you can see, y into integrating factor. This one you have to write. So the solution will be y into integrating factor equals to q into integrating factor dx plus into c plus c. It's not written, so it's c. So simple, you have to write y into integrating factor. You don't have to solve this left hand side, it's already solved. And then q, integration of q into integrating factor, then dx plus c. So that will be the solution for the differential equation. So only this you have to do. Now let's see some examples to solve linear differential equations. So here I've taken this question. It's dy by dx plus 2y equals to sine x. So here first you will see here this is y, so you have to leave this. So your p will be q2 and your q is here sine x. So now you know what you will find out. Here you will find out the integrating factor after getting this. So integrating factor is e raised to the power p dx. So here you will just simply write e to the power 2 dx, and you know that integration of simple 2 will be 2x only. So we got the integrating factor. Now what you have to do is the formula, that is y into integrating factor equals to integration of integrating factor into q dx plus c. So that only you have to do, and I'll just put the values here. So e by into e to the power 2x equals to integration of e to the power 2x into q is sin x dx plus c. So now you have to solve this. Now we have to integrate this part. So let's take this one I. So that I equals to, here actually you will not get the integration in one step. So you can take it I and you can solve it. Then we will put the value back here. So now here, it can be written as e to the, here we will use the by parts. So here you can use the eyelid. So eyelid says like first we will take the sin x. So sin x integration of e to the power 2x dx and minus differentiation of the first function, that is sin x, then integration of the second function, and then integration of whole plus c. So now we will simplify this thing. So here we get I equals to sin x will remain and e to the power 2x will be e to the power 2x divided by 2. Here we'll get e to the power 2x, it will be half e to the power 2x. So I'm just taking the half outside. So we'll get here a differentiation of sin x is cos x, then e to the power 2x by half, I just taken already, by 2. And then we have to integrate this thing and then plus c. And now we don't have to do anything with this, and then we will take the next one, that is half. Then again we will use here integrate it. So again you can see your cos x will remain same, and then you have to integrate e to the power 2x dx. Then here, so then you have to take a minus, and then you have to integrate differentiation of cos x, then integration of e to the power 2x dx, then integration of this whole thing. And then here you can write e to the power 2x into sin x divided by 2, here minus half, and then you will get here cos x into e to the power 2x, then again one more 2, and then this minus minus will become plus. So in these questions you have to make sure if you are taking care of these minus and plus signs. So here it will be plus, and then you will get here differentiation cos is minus sin x, sorry, cos x is sin x minus sin x, so it will become minus again, and then into we have here e to the power 2x, so it will be e to the power 2x divided by 2 again, and you have one half from outside, so that half I'm writing here, and then you have to integrate this whole thing, just writing it like this. That's it. Now you can see e to the power 2x sin x, this whole thing is same as the I. So this is your I only. The integration of this we have already taken as I, so we can replace this thing with I. So here you'll get, see, minus sign you'll get, here you'll get 1 by 4, and this whole thing will become I. So this, here we have right side I, so we have e to the power 2x and half, or you can see e to the power 2x half, you can take common also. So here you'll get only sin x, and then here you'll get minus cos x divided by 2. Now we can write this thing as 5 by 4i, because this minus 1 by 4 you can take to the left side. So I plus 1 by 4, here you'll get I plus 1 by 4i, so that will result to 5 by 4i equals to e to the power 2 x divided by, here you can take LCM also, so it will become 4, and then it will become 2 sin x minus cos x, and then here 4 you can cancel, so I will be e to the power 2x by 5 into 2 sin x minus cos x. And then now you can take this value back in the equation, which was let me show you the equation. So here it is. So the equation was this y into integrating factor, this was the equation. So here we can put the value back. So here you can write So here you can write y into e to the power 2x equals to integration of this whole thing we have already calculated. So it is e to the power 2x divided by 5, then twice of sin x minus cos x plus c. So that will be the answer, and you can a little bit more simplify it. So you can write it as like you can divide it with e to the power 2x. So you can write it as y equals to 2 sin x minus cos x divided by 5 plus c e to the power minus 2x. So this you can write as answer. So this will be your final answer.